Today we are going to study the simple ranking cycle in which first of all we have to know the difference between the gas cycles and vapor cycles and discuss about the gas cycle. In the gas cycle the working fluid is gas and there is no phase change during the whole cycle. Air is working fluid and it is T versus V graph for the gas cycle. Then discuss about another cycle, the vapor cycle. The vapor cycle, the working fluid is vapor. During the cycle, the phase change will occur. It is liquid at some point in the cycle. And then these are the diagrams showing this whole steam power plant in which the all components are present here. Then discuss the main. They are discussed about the main components of steam power plant. First one is boiler, turbine, condenser, cooling tower, and pump. And then first we discuss again the simple ranking cycle shown in the figure, the main diagram and the tier diagram is showing in this case. Then discuss about from the graph we can conclude that what is the meaning of 1 to 2, 2 to 3, 3 to 4, 4 to 1. 1 to 2 isentropic process, 2 to 3 isobaric process, 3 to 4 isentropic process, and 4 to isobaric process. Then discuss about the main functions occur in the different sections of the ranking cycle. The boiler. Then discuss about the in boiler section. The boiler is used to produce the steam. The heat energy produced by coal is used to produce steam. Water is allowed to heat until it becomes into the vapor state. Vapor is sent to the into the boiler, into the turbine. Then discuss about the turbine section. The turbine produces the work. That means the work output done in the turbine section. The work produced is used to run the generator. And then enthalpy at the inlet and the exit of turbine are different. That means enthalpy H1 and H2 is different. Then vapor is sent into the condenser. That means the in turbine section, that means the work output will be obtained in the turbine section. Then discuss about the condenser section. The vapor is condensed to water in the condenser and sent into the pump. And that means the heat rejection, heat addition takes place in this condenser section. That means the heat is rejected by the steam and the heat gained by the cooling water. And then discuss about the pump section. The pump sent water again into the boiler and the cycle repeats once again. That means again the pump has a function to raise the water from bottom to top. Again the water is entered the boiler and then boiler steam is generated and the steam is entered the turbine and the turbine steam is expanded and the work output done. And then the remaining steam is entered to the condenser and the steam is converted to the water in the condenser and then condenser again come into the steam or water enter into the pump and so again the same repeats the cycle once again. Then discuss about the energy equations, so energy balance equation in the ranking cycle. The first of all so the turbine section, then condenser section, pump section, and boiler section. In turbine section, H1 W turbine equal to H1 minus S2, Q rejected. That means in condenser section S2 minus S3. In pump section W pump H4 minus S3, and boiler Q added heat added H1 minus H4. From this diagram we can this one, and then discuss about the what is the actual condition happening in the ranking cycle. In TS diagram we can showing that 1 to 2, 2 dash, 3, 3 to 3 dash, 3 dash, 3 double dash, 4 dash, and 4 double dash. And from this diagram we can conclude that turbine produces the more work if the water is heated to superheated region. If the water is heated to superheated, then the turbine will produce the more work. But there is a problem: the water is heated to superheated, that is when it is condensed and the vapor is not converted into the water completely, it remains still as a mixture. That means in the case, suppose the steam is converted into the vapor, no problem. But steam is not converted into the vapor directly. The steam has a mixture of water and steam. It makes problem. That problems created the cavitation, and it is difficult for the pump to handle the both liquid and water, which leads to cavitation. The cavitation phenomenon occurs in the turbine section. Then discuss about the turbine section. Cavitation means the sudden formation and collapsing the air bubbles around the impeller when they move from low pressure region to high pressure region. Cavitation does not show a quick effect on the pump, but if the cavitation continues regularly, it destroys the pump very badly. And this is the end of the today's session.